Thanks for joining me with Outside Plant Fundamentals. This is a channel to talk about the fundamentals of outside plant. So this is currently a 5-part series we're doing on poles and aerial work. This one is going to be about pole terms and the zones on a pole. All right, to talk about the zones on a pole, first we have to talk about the pole, right? So utility poles generally last about 45 years. Depending on the weather and the temperature, of course, could be a little less or a little more. They are, generally speaking, wooden poles. So poles are categorized by two features: the height of the pole, which is obvious, how tall is the pole, and then there's the class of the pole, and that's how big around the pole is. So those classes go from class 1 to 5. For the biggest majority of poles you see on the side of the road are between 1 and 5. Class 1 being the biggest around, the heaviest class, all the way down to pole class 5. Now there is a class 6 through 10. Those are only comm poles. That means there's no power on those poles. And there are steel and concrete poles that you will see. Generally, they're used for transmission, but you can attach to some concrete and steel poles. They are only class 1 through 3. So pole heights start at about 20 feet tall. They go up to about 60 feet for most poles. You will occasionally see a 100-foot wooden pole, but poles that begin to get over 60 feet generally are the steel and concrete. So when you're looking at a pole line along the side of the road, there's a few terms that you would use. The distance between the two poles is considered the span of the pole. Then you have your point of attachment. The point of attachment is where the bolt is drilled through the hole and we've attached to it. Then we have the sag between the poles. So I know we've all seen that there's the cables between two poles kind of sag down in the middle, and that's actually on purpose. If we were to pull those cables very taut, then as temperatures changed, hot to cold, wind blowing, and those cables were that tight between the two poles, they would actually eventually just tear down the pole because the cables weigh so much. So they actually put that slack there to allow the poles to have a little room to expand and contract without putting too much tension on the poles. And we call that the sag. Now the sag is based on the span between the two poles and the weight of the cable, and how much sag is allowed on your particular cable is determined by the power owner, the pole owner, and your NESC. Now, generally in urban and suburban areas, when you're in town, your poles are going to be about 125 feet apart. In rural areas in the country, they will go up to about a maximum of 300 feet apart. You will occasionally see ones that go a lot further than that, maybe 400 feet, but they're going to have a lot of anchors and guys on them. And in future videos, we will talk about anchors and guys. Then the term that is most often misused is the midspan. The midspan is the point of the sag that is the lowest to the ground. Most of the time, the midpoint is exactly between two poles. So if you have two poles, where the center is the midspan. But what you're really talking about is what is the lowest point that the cable will sag down to the ground. And in cases where you have one pole that's up on a hill on one side of the road and the other pole is at, the same level as the road or maybe down in a ditch, and those two poles have a really different height, then the midspan is actually going to be closer to one pole than the other, because the midspan is the point that the cable sags down closest to the ground. And in most cases, that's the road. But it's what is the lowest point of that cable. So on a pole, there are 4 zones. No matter where you are in America, there's always going to be 4 zones on a pole: power zone, worker safety, comm zone, and your traffic zone. So your power zone is that portion of the pole that is used for everything that has to do with the power company. That doesn't just include the power lines, but it's your drip loops, transformers, street lights, any equipment that the power company uses to bring power to your home or to a substation, that is the power zone. If you want to know precisely what that equipment is, you can check out your NESCs. Now, the one thing that might be different in different parts of the country or in different companies that you work on is exactly what they call that zone. Some places call it the power space, the supply space, the power zone. Regardless of what they call it, it's the same zone on the pole. Now, within that zone, you're going to have a lot of things going on, and you're going to have not only distribution power bringing it to your house, but you're going to have transmission power. Now, distribution always ranges between 4.6 and 34.5. Transmission lines going from substation to substation are 69 kV up to 345 kV. But there is this weird zone in the middle from 69 to 115 where it could be either phase, transmission or distribution. Now, when we look at this diagram, the cable that I need you to look at is cable 8, which is your multi-grounded neutral. And we're going to talk about that a little bit later. That comes into play. So when you're looking up at a pole, there are a few ways to tell the difference between that distribution and transmission on the pole. And the reason that's important is we're going to talk about later when you're applying to attach to that pole, what type of power is on that pole is important. So the number one way to know whether something is transmission or distribution, generally speaking, is the cable hanging below the insulators or above the insulators? Pretty much always, if the cable is below the insulators, that's going to be a transmission line. If it's above, it's a distribution. And then there's that weird area between 69 and 115K where it could be either way, right? Now, the reason that we have insulators on these power lines is to leak off the high voltage current. So the cables build up static the same way a person would walking across the carpet and you touch a doorknob. These cables build up that same type of static, and these insulators allow that static to bleed off without building up and causing a problem. So you can tell by the larger number of insulators, the more power there is on that line. So the reason this is important is most power pole owners do not want comms or communication attachers on their high power transmission lines. It's a safety hazard, and there are exceptions, but for the most part, we don't attach to poles that have transmission. One of the few exceptions is, like I said, that 69 to 115K. In those cases, they will often let communication companies attach to those poles. So in those instances, when a power company does have high transmission lines on a road, they will often provide distribution power and comms on the other side of the road, just like the photo we have here, where they're providing a place for the communication to attach, but they don't want it on the transmission. At any time that you have an option like this, where you have pole lines on both sides of the road, the pole owner will always push you to one side of the road and not attach on both sides of the road. I also have a photo here of one of the odd type where you have a 69 to 115K transmission line. It could be distribution or transmission. Just looking at this photo, I couldn't tell you the difference. I could just tell you this is that weird range where just looking at the pole, you couldn't tell the difference. So then, like I talked about with the power and the transmission, we have our worker safety zone. And this is a safety zone because the people that are trained to work on the power lines are generally not the same people that are trained to work on that communication space zone. And so what they've done is provide this safety zone that allows for if the power cable were to arc or have a static discharge, that is a amount of space that the person working within that communication space should feel safe from those distribution lines. That worker safety zone is 40 inches. On every pole, it's always 40 inches. There's only a few exceptions to that rule. For instance, like I told you in the previous slide, that multi-ground neutral, there are instances where they will let them be 30 inches apart, but for the most case, you should always assume 40 inches. Now, depending on what part of the country you're in or the company you work for, they might refer to that zone slightly different, the worker safety zone, the neutral space, and they may also call it the MAD zone. MAD stands for the minimum approach distance. Then we come to our COM zone. This is where all of your communication attachers will be. There'll be telephone, coax, cable, fiber optic. We are all in that same COM zone. Within that zone, we all have to be 12 inches apart at the point of attachment. So we talked about that term. That's where the bolt goes directly through the pole. All those attachments have to be 12 inches apart. The exception to that rule is the equipment that might be on the cable. So you might have a slack loop, a splice case, a slack coil, a snowshoe. Those can be up to 4 inches away from the other attachers. That zone is almost always called the COM zone. It might be called the COM space. Now, when we're attaching strand to the poles, we always want to attach our communication lines to the road side of the pole. So that might mean that switching from one side of the road to the other, you're switching from one side of the pole to the other, and then it can even get in trickier when you're at intersections and you have multiple cables going on the same pole. Now, that is the way it should be done, but there are instances where you might see communication lines on two sides of a pole, and this is called boxing the pole, and this is a violation. This is not whatever should be on the pole. But this does happen. Sometimes poles have been standing for a lot of years and things have happened over time. Sometimes there's been weather or somebody might have hit the pole and it fell down, and when the power company was trying to restore the pole, there's not enough slack and the cables end up getting on both sides of the pole. This is a violation. We should not ever see this. It's called boxing a pole. Then we come to the final zone, which is your traffic zone. And this one's going to vary pretty wildly. If you're over a railroad, you should be at 27 inches. Now, there are some current attachments that are at 22 feet, but any new attachments should always be at 27 feet over the railroad, and that is from the top of the tracks up to the midspan should be 27 feet. Now, if you're crossing commercial driveways, or if you're on a DOT owned road, you're going to be at 18 feet because what they're allowing for is tractor trailer, 18-wheeler traffic. If you're on a road, if the pole line is parallel to a road, or it just has driveways, like any kind of driveway, those can be at 15. Driveways that you would assume you would not see a tractor trailer on, right? Those can be 15. Pedestrian traffic only, so that means if there's only grass under that pole, you can be at 12. Service to a home, so that is the drop cable from your home, from the pole to your house. That's the service to the home. That could be at the lowest point on that cable can be 10 feet. And then the one that is most difficult, which is your water crossings. So when you have a water crossing and it says no boats, what it means is boats with motors. So if it's a body of water that you could do a canoe or a kayak, that could be 14 feet. But any body of water where you could actually use a motor on that body of water, it is the jurisdiction that has ownership of that body of water that determines what that height is. So it could be a city, a state, a county, or it could be the Army Corps of Engineers. They determine what that midspan has to be for the types of boats that could possibly pass underneath it. So obviously the reason we care about that traffic zone is because we don't want trucks tearing the cables down off the poles. So we're going to do an example here of how these zones are actually applied to applications. So you have your power zone, and in this example, we have 60 inches of power space. We have our neutral space, our worker safety zone, which is always 40 inches. We have our COM zone, so we have we probably have 3 attachers on here at 40 inches. And then let's say we're on a DOT road and we have 18 feet of a traffic zone. So that brings us to 29.5 feet, so we could easily accommodate this on a 30-foot pole. If you're the new person attaching to this pole, the only number on this example that would ever change is your comm space, right? Your power stays the same, worker safety, traffic. But in order to accommodate that new attacher, now we have to change out that pole from a 30-foot pole to a 35-foot pole. And we're going to talk about that more when we talk about the make-ready engineering and the pole load analysis. Thank you so much for watching this video. I hope you'll like and subscribe and join me for the future videos.